Yeah, because like
Mm-hmm.
mm, it's not as bad.
I think physically moving around is also a good thing. It's also good.
Yeah.
But do tell me if things get too much, or you feel that you cannot take it for a longer time. You should tell me or somebody else. Okay,
Mm-hmm.
Tristan?
Okay.
All right. Okay. Now, well, how about your math?
My math, the WA is next week, so
Mm-hmm,
still got a lot of
mm-hmm.
time.
Do you know the topics and everything? Yeah.
Yeah, the topic should be let me check. Should be chapter 3 to 6 if I'm not wrong. If
So
not, then
you
it's
are
chapter 4.
okay. So you are still practicing what you're supposed to do, like this application thingy, right?
Yeah.
Okay. Sure, we can do that. Is that some sort of homework that you're showing me?
Yeah, this is the homework.
Yep, I don't foresee any difficulty, but if you want to talk about it, seems good for the exam. Okay, let's do so. Ria, have you sent me something, Ria? Ah,
Yeah.
you did. I'm sorry, I missed that. Okay, okay, I did. Now let me see that. Okay, immediately. And then you're gonna tell me. Okay, introduction to da. Yeah, sure, electrochemical cells. Yeah. Term 2, week 4. We're currently at term 2, week 5, is it? Week
Yeah.
4 or 5? We're
Five.
term 2, week 5, so we're commencing. Okay, sure. What's this Viva test, right?
Mm-hmm.
One. I have a disconnect just now. Can you hear me again, Ria and Tristan?
Yeah.
Yes.
Okay, thank you very much. Okay, so with Ria first. Okay. Okay, Ria, I almost finished reading it. Oh, there's remarks. Okay, good. Yeah, nice. Okay, documentation. Sure, 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 sure. Okay, okay. Mm, What is Viva test?
Oh, it's just
Is
like a question and answer thing.
you mean in front of the class?
Like in front of the teacher. Yeah.
So personally, something like that?
Yeah.
So it's a very quick presentation to him and then Q&A.
Yeah.
Because in the requirement, I see that it is you communicating. It's more like you instead of him. He will probably ask some questions lah.
Mm-hmm.
Every team, huh? It's a team thing. Team.
Yeah.
Okay. Two two multimeters only. How many team is that?
Uh,
How many team?
like how many people in a group?
No, no, no. How many team in the class?
Oh, like 10.
10 team sharing two multimeters. Brilliant. So one multimeter shared by five. Okay. And then your team member is 4.
Uh, there's 3 people in the group.
3 people in the group, including you, I understand. Now, tell me, how well will you guys work together? Realistic assessment, please.
Pretty well.
Pretty well. Pretty well is very good, right? This is a project in the end.
Mhm.
Now, you asked me about an idea thingy. So who's the idea guy in your team?
We all came up with like one each. So
Okay, you can tell me later. I understand. Before we talk about it, this will be a lot of discussion. Let me confirm that. Is there anything else that you want to discuss today?
I think after like this part, we can do electrolysis questions.
And that's fine. And I'm still not hearing any homework from your teacher. Really, there's just no homework.
Yeah.
Okay. So your standard is currently set by the tuition. Okay. Weird, but we can deal with that. Okay, now I'm going to alternate with Tristan because Tristan is facing exam also. So both of you will be discussing quite a lot today. I want you to alternate between discussing this and doing questions, because if not, you have too much waiting time, and I do not want too much of a wait time. Can we do that?
Yeah.
Okay, so you go and take 1 or 2 questions. Electrolysis again. Okay, has teacher has. Yeah, okay. Go and take electrolysis. Go and take electrolysis question, especially if the ones with battery. Okay. Go and take 2, put it in. I'll discuss with Tristan. I'll go back to you. Okay. Tristan, any questions so far?
No. No question.
Doesn't look very difficult. So okay. Okay, fine. Okay. All right. So I'll trade between 2-3 minutes. Yeah. Okay. Back to you, Ria. All right. Then when we are discussing, you tell me now the ideas that your team has.
The first one is like the potato one, but that's not really creative, I guess, because a lot of people would do that.
Sorry, I don't get what you're saying. Sorry. Try again.
The potato one.
Oh no, never mind. You're not gonna get 1.2 volt from. Maybe you can, but potato is not high EMF, a bit difficult, not compact at all, but unfortunately everybody knows, so you can also cannot creative. So, right? Cannot. So that's a challenge. Okay, next.
Aluminium air battery.
Aluminium and what, sorry?
Aluminium and air.
Air. Okay, tell me a bit more about that.
So like you wrap a piece of aluminium foil around activated charcoal and place the aluminium air electrode and a second electrode such as copper in separate containers filled with salt water and then connect it.
Wait, where's the air part?
The aluminium foil reacts with oxygen in the air and the salt water to produce electricity.
It's not air, but it'll work. It'll work as a battery. It'll work. Of course, the potato one also work. But will this be 1.2? You will find out soon. Which concerns me a lot because you guys just have 2 multimeter. What nonsense.
Yeah.
Yeah, it doesn't make sense. It just doesn't make sense. That's the first thing to do. That's the first thing to do if you want. Ria, where's your home?
My what?
Your home.
Oh, Choa Chu Kang.
Okay. Your team members are around there. I mean, do you know?
Yeah.
You guys can work together, right? That's what you're saying, right?
Yeah.
Okay. You guys can, agree with certain things and then divide the work or whatever, or do something together. You guys can do that, right?
Yeah.
I can send you more, even more than one multimeter. Multimeters, I mean, the school one will be a bit fancier, a bit more accurate. Doesn't matter, right? Yeah, I can send you so many multimeters so that you guys can just experiment at home lah. Because you gotta change and swap material, ma. How can you measure things without even having a multimeter at your own disposal? If you understand what I'm saying. Okay, so I mean that's my idea. I feel strongly about it that you should have a multimeter, but it's still up to you guys. You guys want a multimeter?
Yeah.
All right, so that one's settled. Okay, just send to you guys. Okay, you guys have less 3 weeks lah, right? So I guess I better send you guys soon lah. Yeah, that's one. That's one. So you want the aluminium and the copper. Now, instead of calling aluminium an air battery, it's more like aluminium and copper. It's more like that. Okay, and the aluminium now tell me why aluminium?
Uh,
The one who gave the
Yes.
idea, why did he or she thought about aluminium?
think it's because it has the highest energy.
It's reactive but easy for you to obtain lah.
Yeah.
All the metals above aluminium are even better, but they become even more dangerous lah, to be fair lah. So aluminium is probably a good choice. I don't mind. Copper also easy to obtain, and copper is low. You guys know that the reactivity between the metals should be far. You guys know that.
Yeah.
Okay, good. So aluminium is a safe and good choice for now. Copper is also safe and good. Lower than that, things get dangerous also or very expensive. Okay, good. Okay. The salt, no comment from now, but salt is in general just a good choice lah. Okay, good. What else? What else? Hey, how are you going to get activated charcoal? Oh, wait, why do you say activated charcoal? Sorry, why do you say that?
I think it's just an example of what it could do, but I don't know what to replace it with or like what's easier to get.
Now you know that in electrolysis, if you use the graphite, you're hoping that the anode and cathode will not react, correct? You're hoping, right? In the battery, you actually want one of them to react, which is the aluminium, right? Aluminium. Wrapping it in activated charcoal may help in terms of just wrapping it, but it won't help increase the reaction or decrease the reaction also. So it's better than wrapping in another metal, right? But the point is you want the aluminium to react. That's already clear. So whether you wrap it in something or not, the focus is at the aluminium. And you seem to know that the aluminium will react. You seem to know. Okay, clear, yeah? So if you know that, then at least I am no. Well, just if you no, yeah. I mean, strictly speaking, it is not needed for the battery to work. Strictly speaking.
Okay.
Clear, yeah? Because again, you want the aluminium to react instead of not wanting it to react, and the copper will not react no matter what, right? No matter what. Okay. Not sure whether that would be high EMF. You have to find out yourself. The creativity challenge, I think, is a starting point because the material used is a good idea, right? Compact battery, that will depend on its design. There's something else in play here, which is very weird. I find that it's very weird that you're okay, that's that. Okay, do you want to talk about the second idea again, or do you want to talk about the third idea first?
The person didn't really explain more about it, but it's with coins. I can't tell it.
In terms of material, you want to use coins, right?
Yeah.
I understand. Please do questions first because it'll refresh you on the technicalities anyway, right? It will. And then we'll get back to the ideas. Okay? Okay. I want to see some questions first, right? I think I promise we will go back to the idea. Tristan, any questions so far?
No, I'm just checking all the math stuff for the WA.
What worries you the most right
Mm, maybe all like the linear questions.
now? Sorry, you mean the word problem, or do you mean
Oh yeah, like the
what? Sorry,
word problems like that.
if that worries you the most, we should probably just go to the Google Drive and get more word problem questions. Probably that's what we should do. I agree that I don't think you'll face a lot of trouble elsewhere lah. I don't think so. If you agree with that and you're comfortable with your homework, I don't think you should do your homework in tuition today. I think you should just practice for exam. Don't
Yeah,
go to
okay then.
Google Drive.
Maybe I'll just do some. Maybe I'll do this.
Maybe do one or two, maybe. Yeah. Yeah, sure. Estimate. One question number 2 is estimate. I don't want question 1.
Oh,
I don't want. I
okay.
want question number 2. Yeah. Question number 2. The estimate question. Remember estimate, yeah? Let me see whether you remember what I told you. Okay, Ria, it's page 20 already. Oh, Ria, this is page 20 already, isn't it?
Should I
Okay.
create a new?
Yeah, you can create a new one. Share with me. You have to do it anyway. So, tell me when you have shared with me, okay?
Should I just send the link in the chat box?
Oh no, you just share with me. I will be able to see it, so to speak. Can you share? Sorry, do you know how to share with me?
Yeah, but I don't have your email.
There's a share button on the top right.
Yeah.
And then if you don't know my email, for now I'll type it for you. Okay, I've sent the email for you. Okay, I've seen your decision, Tristan. Seems helpful, right? Seems helpful. Use the curly. No, sorry. No, it's not. No, sorry. Yeah, seems like a good idea. Good, Tristan. I think you get it. I would like you to skip question 1, question 3, question 4, right? Let's move on to the question. Maybe just do question 5, just as a practice, and then we move on to the next page.
I think it says I can't share it with you, so I can give you the link.
Okay. That's so weird. Okay. I'm not sure why, but we don't solve technical problems. Okay, I'm going to create one and share with you instead. Okay, that should work. Okay, what's your email? Tell me. Just say it.
RIYA.
IYE.
RIYA.
IIYA. And
Underscore.
I don't. Oh, okay. Sorry.
Should I
I
just
typed
type
it wrong. No, I got it. Ria Prakash, right? Yeah.
Yeah. RYA_PRAKSH.
I just sent it to you. Right now, you access it.
Okay.
Okay. All right. Put in your questions first. Let's revise our technicalities, and then I'll show you something. Kristen, are you okay?
Mm-hmm.
Good. I like it. I like it so far. Priya, to confirm, this is electrolysis or battery?
Both?
No, it cannot be both. It's either electrolysis or battery.
Electrolysis.
3 reasons. There's a battery.
The battery.
First one. Then the battery is really detailed here, right? So, and then the electroplating. Electroplating means plating with electrolysis. So, yeah, okay, that's another thing. And then he actually really say the ion support are too big to be plated in a normal electrolysis tank. So that's really he's telling you clearly that this is electrolysis. Okay. Now, so far so good. Now, please try to do it first. Are you stuck, Tristan?
Yeah, a little bit for this one.
You can choose one K first because he say basically can choose, right? So which one?
3. Choose
Okay,
3.
so let's stick with 3, and then this is greatest and smallest again. The thing that you did very well last time. Are you stuck if we say the K is 3?
Integer is like the number, right? Like multiple.
It's just
Think-
that you cannot go to decimal point. That's all it means.
Oh, okay then.
That matters a lot if you're talking about K equals to 5. When it's K equals to 3, don't think you will have any problem.
Okay.
Priya, you start.
I think it's decreased, but I don't know why.
Let me see the brush sticking again. And that is fine. Your answer is actually correct. Your answer is fine. Now you're saying that you do not know why.
Yeah. Like, I don't know what it means by like the biggest. So does it have to be times 10, times 100, times whatever?
Sorry, I was talking to Ria,
Oh,
but I want to talk to you now,
oh,
Tristan.
okay.
Okay, Ria, your answer is correct. If you do not know why, do another one, and I will have to discuss this with you. Right? Okay, Tristan, I put it in the Jamboard. Okay, right. So when you talk about a equals to 3, that means you are concerned about 3, 6, 0. You're just concerned about these three numbers, correct?
Mm-hmm.
Now, how can, so the difference between the greatest and the smallest. So how can this 37,600, right, be 3 or 30? Cannot be, right?
Oh.
Cannot be,
Oh.
right? Again, you're supposed to think that way, right? Okay, it's fine that you guess this number, but you don't do the checking, so to speak, so that you kind of uncover if something is wrong, right? Right. So remember the check. Oh, you're continuing, Ria. Good. Otherwise. Mm. Just to confirm, Ria, that you are seeing my writings.
Yeah.
Back to Tristan first. Tristan, you don't have any new guesses right now.
I'm trying to check for the guesses. But yeah.
This is a bit weird, Tristan. All right. Okay. So, okay, check this out. Okay, the smallest one. So smallest should be smaller than 37,600, right? So
Mhm.
let's say I put 37,500, which is definitely smaller lah. Is this a correct answer or not?
Um.
How do you check whether this answer is correct or not? Again, how do you check? Calculator does not help. Trust me, calculator doesn't help at all. Remember, this is the result of the rounding off, right? The result of a rounding off.
Oh yeah.
So my guess, 37,500, if you round it off, will you get this? Will you get it?
Oh yeah. Yeah, you will.
To three significant number, right? Three significant.
Yeah.
So if you round off 37500, this is already 3SF, right? In that sense, already 3SF, and therefore he will stay 37,500. There's no reason for it to round off to 37,600. Am I confusing you right now?
So if that's the smallest number, would the biggest number be 37,900?
No, if it is 37,900, I can tell you right now, well, this also seems to be 3SF, but this 3SF will simply stay 37,900. Why would it change? My first point is, if you're thinking about the smallest number possible, you should make your choice more than 3SF. Maybe 4, maybe 5. I don't know. I'll keep that open. Why do I say this? It's because there is no. Usually, we don't round off a 3SF number to a 3SF number. We usually round off a bigger SF to a smaller SF. That's why.
Oh, yeah.
That is why we round off. So let's just say that the guesses should be 4SF or 5SF, definitely not 3SF.
Okay.
So let me give you an example. For example, 3, 7, 5, 10, right? There, I put 10. So it's now 4S, right? Now round this off to 3SF. Now, the rounding off part, you should be able to do. Don't look at this, okay? You don't look at this number. The question is, what happens when you round off 37,510 to 3SF?
It becomes 37,500.
Which means my answer is wrong, right? Simple, right? 520. Still wrong?
Yeah, still wrong.
Good. 530. Still wrong?
Yeah, still wrong. Until it's 50.
540. Still wrong. Okay, now 550. Then I am now back to 37600, correct?
Okay.
Okay, is it possible to make it 5SF? I'll leave it to you. Now you have to do the same process with the larger number. Okay. Remember, this is how I teach you. Not
Okay then.
thinking about it too much, It's not about thinking about it. Okay.
Okay.
Ria, why are you? Oh, Ria, why did you rewrite things? Okay, Ria. Okay, Ria. You're still in question number 1, right?
Yeah.
Okay, right. So the concentration decreased because the zinc 2 plus, right? The zinc ion are zinc 2 pluses. They are not zinc. Am I making any sense?
Yeah.
Which one is metal?
Zinc.
Good. And the zinc 2 plus, they call it metal ion. Very confusing. They're just ions, whatever. They're just ions. Ions are not metals. So the concentration of zinc 2 plus decreases because you already given the answer. There you go. This is the answer, isn't it? That's the Y. Correct? That's the Y. Am I making any sense? Sorry, are you seeing my working here? Ria?
Yeah.
Okay. Am I making any sense? This is the Y.
So it decreases because it loses electrons.
And becomes zinc 2 plus. I mean, if the reaction is to be believed, if your reaction is correct, right? Then can't you see that zinc 2 plus is the material, right? The raw material, and it will be used up. Once the reaction happens, zinc 2 plus no longer is zinc 2 plus. I mean, if zinc 2 plus remains zinc 2 plus, that is not a reaction, if that makes some sense.
Yeah.
So, platinum, will not react. So let's say your reaction is correct. Concentration decreased because of that. That will be part of your answer for part 3. In part 1, you don't have to explain why you're correct. Part 3, you will be needing this. Okay. Now, any question before I talk about part 2?
No.
Then in part 2, do you know why it remains the same?
Because it's the same material.
And that would be incorrect. Now, this is the half equation at iron, right? At iron. The way I teach you is you gotta draw the electron flow, correct? That's the first thing I teach you. Your teacher might not teach you this. Follow me. Yeah? So at iron, you're saying that the zinc 2 plus receive electron. That makes a lot of sense according to the electron flow. Of course, the electron is flowing into the iron. Make sense?
Yeah.
Now, what's the reaction on the zinc brush? So the other half reaction at the zinc brush. Now you tell me, what's the reaction there?
Zinc.
Write down, write down.
Wait, does this include zinc sulfate?
This is not how I teach you, right? And you lose a lot. You lose a lot. Let me remind you how I teach you. First, electron flow. Secondly, list down the competitors. Okay. So who are the competitors for the reaction here? Okay. So let me ask you, is it the negative ions or the positive ions?
Positive.
Oh goodness, you forgot everything already. Now, there are two reasons why the positive ion will not react here. First thing first, the positive ion will not approach the positive end of the battery. The positive ion will approach the negative end of the battery. Am I making any sense? If you memorize this, you're gone already. You gotta understand this now. You sure you understand? The positive ions will approach this instead of that. And therefore, here, your reaction is a positive ion, which is why your reaction is correct. Because positive ions do approach here. Which means negative ion approaches here, because, it's a positive end of the battery. That's the first reason. The second reason is this is losing electron. Losing electron means getting more positive or getting more negative.
More positive.
Now, will a positive ion be more positive, or will a negative ion be more positive given the chance?
Positive ion.
Will not become more positive. Let me show you. Will zinc 2 plus become zinc 3 plus? As far as you can tell, huh?
No.
And why is that so?
Because it's attracted to the negative.
Not wrong. The other reason is zinc 2 plus is already happy. The way we say it's happy, because the valence electron is full. That was the reason why zinc become zinc 2 plus in the first place, to be full, correct? To be full, correct? If he loses another electron to become zinc 3 plus, he is no longer full. And he does not want that at all, if that makes some sense. Positive ion do not want to lose electron, if that makes some sense. No way. Can you?
Yeah.
Don't memorize this, understand it, at least understand the way I think, and then hopefully make it yours. Make it yours. Now, for the reaction on the positive brush. So one more time, negative ion or positive ions?
What? Wait, what was the question?
Reaction on the positive brush, right? Negative ions or positive ions. Does this make any sense?
Negative.
All right, and what are the candidates? Which means what negative ion exists? The competitive
SO4
stuff.
2 minus.
SO4 2 minus. All right. Anything else?
No.
That would be wrong. This is aqueous. So what does that mean?
Oh. OH minus.
Is another candidate. Now, is there any other candidate?
No.
There is one more. The brush itself. The material of the brush. Now, this is how I teach you. When the material of the brush or the anode or the cathode, whatever, is not inert. There are only two inerts, graphite and platinum. Now the brush is not platinum, the brush is zinc. Zinc can possibly react, possibly. You gotta put it in the reaction list or the candidate list first. And then you think about it, whether it will react or not. Do you understand?
Yeah, but it doesn't give the material, so do you just assume?
I'm sorry, it does what? It does what? It doesn't?
It
It does.
doesn't give the material of the brush in the question, so do you just like assume?
No, part two. Part two is made out of zinc.
Oh, part 2.
They did give it in part two. They did. Like in part one, they finally give it, which is like what they're supposed to do, But part one, platinum. Oh, okay, I got it. Not gonna react. Part two, zinc. Oh, okay, get it. Might react into the candidate list, into the competition. Would that be okay?
Yeah.
Okay, so now you have your candidate list. Who will win? SO4 2 minus, OH minus, or zinc?
OH minus.
And they'll be wrong again. Now, however, correct SO4 2 minus will not win because it never wins. The negative ion rule are very complicated one. First thing first, this guy never wins. So you're correct, you don't choose it. By right, OH minus wins. However, zinc will definitely win more. Because when zinc loses electron, it becomes this, correct? That's losing electron. When OH minus lose electron, do you remember the reaction? Okay, good. Now, Ria, you did mention that you have your own notes and you did spend some time making your notes, right? Remember that? I think you said that back then, like 1.5 months ago, you prefer it to not be on the Jamboard, but you prefer in a physical note, something like that. Am I correct?
Yeah.
Do you have it right now?
Yeah.
I want you to read that. This OH minus reaction is definitely there. I want you to read it and find it. This is a test whether your note helps you or not. This is not a test of whether you remember or not. Of course, you won't remember. It's so rusty, but will your note help you when you don't remember? Okay, that's my question right now. Now, Tristan, I've been following you. You've done around 3 questions. Have you checked the answer key just to be sure? No, have you checked the answer key? I think you're muted, I think.
Yeah, I checked the answer key.
If you're correct, then good. Good.
Yeah.
Okay, do one more lah. The 11 one, it's fine. I like it. But one more and then we'll shift topic already. I think you're fine now. Is that your answer? Yeah.
Yeah.
Now, your answer is not correct. Why? Because this is a removal of electron. Removal means minus, if that makes any sense. It should be minus. I am removing 4 electron from 4 OH minus. Minus law. Does that make sense?
Yeah.
If you add electron, it will be not losing electron, but gaining electron. Now, why would the OH minus be losing electron? Why? If you say something, I couldn't hear you.
Not
Okay.
sure.
Foundationally, go back to the first thing I teach you. What is the first thing I teach you? The battery governs the electron flow. It governs it. It will happen according to the battery. The battery governs it, really. You cannot oppose the battery, something like that. The battery dictates that electron will flow this way, correct? That's the
Yeah.
dictation of the battery. It dictates the whole thing. So therefore, will the brush lose electron or gain electron? Or lose electron because of the dictates of the battery? Did that make sense? The ion support will gain electron. And why? Because of the dictates of the battery. That's how it will be. If this makes any sense.
Yeah.
So why will OH minus lose electron? Back to the original question.
Because it's near the positive side, and the positive side loses.
Electron governed by the battery. So this is the correct reaction if you minus 4E. Right? How is it, Tristan? Is that correct? No.
Yeah, this is correct.
Wonderful. Wonderful. Shift topic already. Shift topic already. I want you to practice the word problem thingy. Pure algebra, I don't think you have any problem. Any word problem involving algebra would be great. Yeah, no.
Mm,
Yeah, maybe question 6, maybe maybe this kind of thing, right? Maybe this kind of thing, right? Okay, so back to you, Ria. It's just that in chemistry, they don't like minus law. Minus makes a lot of sense, but they don't like it. So you just put plus 4 electron here. This part, is it confusing or not? If it is confusing, you must tell me right now.
No, understand.
Okay. So the plus 4E on the right-hand side is the chemistry way of saying, hey, the OH minus is losing electron. To me, it has always been very confusing. I kind of hate it. I just wish that they will say minus 4E on the left. That makes a lot of sense to me. But it's a very subjective thing. Now, do you want to upgrade your node before we continue? I want your node to help you when you need it, right? When you forget, that's when you need the nodes. Do you want some time to upgrade your node?
I wrote it down.
Okay. That means we can continue. Is it okay?
Yeah.
All right. Now back to the candidate. So why won't OH minus win even though a reaction is available? This is a very common reaction and OH minus do win a lot. But in this case, OH minus loses out. This reaction does not happen. The zinc reaction wins hands down. This guy wins. Life's complicated in the negative ion side. So now zinc wins. Do you know why?
Is it more concentrated?
It is true that zinc is more concentrated than OH minus. I mean, after all, zinc is a solid. How It's super concentrated compared to aqueous. That's one reason. There is an even better reason. Do you know the even better reason?
It's more reactive.
No. Now, let me tell you the reaction, very important. This is forced, and this is voluntary. Now, what does it mean by forced and voluntary? We go back to Sec 3 first, right? Zinc becoming zinc 2 plus is something that makes zinc happy or unhappy. If you don't know, just help.
Happy.
You're absolutely correct. Because zinc to zinc 2 plus makes zinc happy. Zinc wants to become zinc 2 plus. It's a voluntary reaction. You don't have to ask him to do it. He will voluntarily do it. Of course, if you ask him, he will just do it. Voluntary makes him happy. Which means I declare OH minus becoming O2. There's an O2 here. OH minus becoming O2 is involuntary, is being forced. I am saying that this is less happy, and OH minus originally is more happy. Happier, I'm so sorry. What a bad English. Happier. Do you know why OH minus is happier and O2 is less happy?
Wait, the question is?
Again, the question is why OH minus does not react? Why zinc wins? I declare because zinc is voluntarily becoming zinc 2 plus. It's happy to do so. And I declare OH minus is not happy to become O2. He's being forced to do it. He's being forced. So my question to you was in very detail. Do you know why OH minus becoming O2 is a very forced reaction? It does not make the OH minus happier. It makes OH minus less happy, actually. Do you know that? And do you know why that is so?
No.
Let me try to explain from Sec 3, yeah? Counting on Sec 3 first. In Sec 3, do you learn something like this? Covalent bond is sharing bond, man. Covalent bond is okay, but if possible, let's go ionic. Ionic is even better for the atom or the molecule point of view. Because in O2, in oxygen, a covalent bond, you're still sharing the electron. I mean, sharing is better than not having anything. But in an ionic situation, like OH minus, in an ionic situation, you give and take. Give and take is permanent. So you are happy permanently, so to speak. In O2, you are sharing. So, sharing means sometimes you can use it, sometimes you don't use it. If you share a laptop, sometimes you can use your laptop and sometimes you do not get to use your laptop. So you are half happy, I suppose, better than nothing. That's covalent, no? Covalent is O2. OH minus is an ion, so okay, it exists in an ionic relationship. It is a permanent give and take. It is permanently happier. That's one way to understand why ionics or ions are just better for the ions compared to existing in a covalent bond. Am I making any sense, right?
Yeah.
So therefore, in that simple way of understanding, most of the time that's correct. Ions are always more preferable than covalent bonds. OH minus becoming O2 is a very forced reaction from their perspective. Does that explain why zinc to zinc 2 plus will win hands down?
Yeah.
And that is the hardest reaction or hardest understanding in electrolysis. People can memorize, people can understand. Ria, even though I say that you're rusty, I don't mean that you should memorize this. I really mean that you should understand this. Would you like to upgrade your note?
For the zinc, always win. If it
Not zinc always wins. Zinc to zinc 2 plus is a voluntary reaction which wins against a forced reaction. How do you know the fourth reaction? Oh, it's ionic into covalent. Sketchy from their point of view. I don't like this. You see. Zinc to plus is metallic bond into ionic bond. Oh, they like that a lot. Becoming ions are in general something they like. Let's put it that way. In general, this is like a good thing to think about.
Okay.
When you're done upgrading your note, please tell me and we can continue.
Yeah.
Okay, now tell me, part B2. We were talking about part B2 and we end up revising the electrolysis. I think this is good. Because anyway, you have your project to contend with. Huh? So B2, what will happen to the concentration of zinc ion if the brush is made of zinc? The concentration remains the same. Correct. Why? I'm asking you to write down the half reaction. What's the half reaction there? Please tell me.
Hmm.
Good. Are you sure this is losing electron? I'm testing you.
Yeah.
Okay, good. Does this help you to answer part 3? 2 marks.
Hmm.
Kristen, good warm up. Oh, not yet finished, right? Not yet finished. Right. Oh, very weird. Okay. Okay, sure. Kristen, how come in your working you do not use 6/7? If that makes sense. Usually in a question, they don't give you irrelevant information, right? Usually they are polite, right? The question makers polite. They give you everything you need and everything they give you, you need to use, right? Usually. Now you don't use 6/7. Am I correct?
Yeah.
That is definitely something worth thinking about because usually they don't give you something you don't need to use. They don't just confuse you, so to speak. They don't do that. Correct. Okay, give me half a minute, guys. All right. Good, Priya. The English is fine, I believe. The English is really fine, I believe. Are you confident with your answer?
Yeah, but I don't think it's enough.
You don't think that it is? Sorry?
I don't think that's enough, but
Okay. Let me tell you how to make it like super nice. Okay, super nice. You're good at physics, right?
better, yeah.
Better. which is why I believe you can understand things, because physics you gotta understand, right? I like physics personally also. I'm an engineer, so I'm just more attuned to physics. That's just my preference. In physics question, especially the long answer, this kind of thing, do you know that they like it a lot if you involve formulas in your explanation? Do you know that?
Yeah.
Good. I believe I've mentioned this before. You know that because maybe you're just like them. Formula means a lot to you, and therefore formula can mean a lot in your explanation. I hope that makes some sense.
Mm-hmm.
In chemistry, there isn't much formula, unless you're talking about mole. If you're in a mole question and they ask you to explain, it's totally fine to include the formulas or her calculation. But in chemistry, that is not what usually happens. Instead, in chemistry, there is another thing that is just way more important than formulas to them, the chemists. What is that very important thing? Sorry, what is it?
I'm not sure.
Reaction.
Oh.
Makes sense. Reaction means a lot to chemists, to chemistry teacher. Formulas, using them properly means a lot to the physicists and to the physics teacher. What am I saying? Whatever explanation or whatever reason, if you include reaction properly, they already think you understand already. They like it. They won't reject it.
Mm.
Is there any way you can involve a reaction or two, whatever, I don't know, in order to make you feel more confident in this part 3?
Zinc becoming zinc 2 plus.
Plus 2 electron, I hope.
Yeah.
Nicely at the zinc brush or at the positive or at the Ni or whatever, you get what I mean. The location also very nice. If you write that down before your English sentence or after your English sentence, which one?
Before.
Yeah, because in physics, you write the formula before, right? Not after. Correct. It's a foundation of your explanation. Am I correct to say this? That's what happened in physics.
Yeah.
The reaction here is a foundation of your explanation. You write down before. Give it a try. Give it a try. Tristan, just checking that. Ooh, okay. Are you okay?
I don't know. I have no idea how to do these two.
Okay, let me confirm that the previous work, because I didn't follow it, was okay. It was okay? Okay.
Yeah,
okay.
all four this is okay.
Nah, that one, the last one. Let me see the last one. Oh, nice. Yeah, okay. I was waiting for that. Okay, good. Okay, good. Now this one. Yeah. Follow each other's link. If it is not possible to find. Okay, good. Okay, now let's say your last answer is correct. 0.3x equals to y. Let's say that is correct. Okay.
Mm-hmm.
Okay. Isn't there any door that can make y over x? Isn't there any? Y over x. Okay, Ria, you erase the English, but I don't see any reaction. I literally mean you should write a reaction before. Don't erase your English. No point. Just write a reaction before your English. Like on top of your English sentence. Like you just write, yeah, precisely. You should just write this down. Okay. If you write this down, you're declaring that this is the foundation of my answer, which is a very good foundation. A very good foundation. Okay. And by the way, your English sentence just now is better than your new English sentence, by the way. By the way. Do you still remember that? Do you still remember it? Because it has a phrase that say it is used up. You're supposed to give an impression that this will replenish and then it will get used up. Something like that. Because you're supposed to answer the zinc being the zinc brush replenishing. Well, you have to mention the fact that this is being used, right? Being used, so to speak. That would be the English they're looking for. Okay. Okay, Tristan, your 0.3x equals to y, okay? Just focus on that. Would you just draw divide by x, please?
Okay.
Okay. Now, back to you, Ria. My point in dealing with all this is to increase your confidence. If this doesn't increase your confidence, I have failed to achieve that, right? Does writing the reaction gives you more confidence in your answer? What do you think?
Yeah.
And why is that so? Why do you think?
Because I
Good,
can
Tristan.
visualize it.
You can what? Sorry, you can what?
I can visualize it.
Good for you. You're saying that it helps your thinking, right? Correct, right?
Yeah.
Tell you what, it also gives them an idea of what you're thinking better than your English. Because they are chemists, you know, the moment they see a good reaction, they're excited, they're very happy about it, right? Good for you, good for them. Okay, right. Any other questions?
No.
Okay, now this is not a battery. It's not a battery. Oh, and we spent a lot of time talking about this. Okay. Now, I promise to show you something that helps you, right? Okay, in your team. Okay, so I'll share my screen. Tristan, you ignore my screen sharing, okay?
Okay.
Mm, what is it? So, Ria, I'm showing you something that all GC students know one. So, and it's not very difficult at all.
Okay.
Okay, you may not understand what this standard electrode potential is. Okay, but you can read, right? You can read. You can see all these weird numbers and everything. Okay. Yeah. Now, sorry, are you seeing my screen? Just to check.
No.
You are not seeing my screen.
Oh,
Let me
okay.
try.
Yeah.
You are, yeah, okay, good. Yeah, so now, never mind all this. I just want you to focus on a few things, right? For example, I'm finding for you aluminium. Okay, there you go. Okay, aluminium. Now here's aluminium. Aluminium. Let's say you don't know what all this reaction means. You don't care, but there is minus 2.33, and this guy, just put it as a volt. Just put it as a volt, right? Okay, minus 2.33. Okay, and then notice that if you have a, a, a more reactive metal, that number will change. So I'm gonna show you that. For example, magnesium. You know that magnesium is more reactive than aluminum, correct? You do know that.
Mm-hmm.
Okay, so look at that. Okay, here's magnesium minus 2.7, and here's aluminium minus 2.33. Now, this is the voltage difference, the ideal, the most voltage difference you can get if you change to magnesium compared to aluminium. I'm telling you what the number means. That means you get another increase of around plus 0.37 volt if you use magnesium in your experiment compared to aluminium. Okay, do you understand what I'm saying right now?
Yeah.
this relates to your first goal, ma. The first goal, your teacher say, hey, if you measure with voltmeter, your battery better give me 1.2 volt or more. If you somehow get your hands on magnesium, which is still safe, you get additional 0.37. It's not bad. Not bad. How come this number is available? Because this number is available. People already done the experiment one. Okay. This also tells you if you go for sodium, because people think sodium is more reactive, you only get another 0.01 volt, which is definitely not worth it at all. You understand what I'm saying? Okay, so this already gives you a sort of like a cheat code, so to say, because people have done all the hard work. Now I'll give you aluminium and copper. It will give you a prediction of the best voltage difference you can get lah. So aluminium, I'll just put 0 minus 2.33. Don't know why minus. Let's ignore that for now. Let's go find copper. Copper is way down there. There we go. Copper. Ooh, this copper is very difficult. Wait there. Oh, there you go. Found it. There you go. Okay. Let's use this number for now. You don't know why, but let's use this number for now. This one is plus 0.52. Okay, so what's the difference between minus 2.33 and plus 0.52? Tell me.
Minus 1.81.
Okay, you're a math student. The difference between minus 2.33 and positive 0.52. Come on.
Negative 2.85.
Negative 2. Yeah, I think so. Ignoring the negative sign for a while, this is the highest voltage difference you'll probably be able to get if you use aluminum and copper and make it work. There are reasons why it may not work, but this is the theoretical difference, which is very high compared to 1.2. If that makes some sense.
Yeah.
I'll show you why your teacher has 1.2 volt. Historically, it means something. I'll just show you for a while. I believe it is zinc. Not this zinc.
Are you allowed to replace the copper with like zinc?
Let me show you. Let me show you what happens. We can predict everything here. So there's a lot of copper number here, but I'll use this number. I don't tell you why first, but here's the number. So this is copper, right? And this is zinc. Zinc is in the middle. So zinc is minus 0.76, whatever. Again, what's the difference between 0.76 and 0.52? Plus 0.52. What's the difference? Kristen, are you stuck?
Minus
Yeah,
1.2.
I don't know how to do this.
Okay, give me a minute here. Yes, Fiat, sorry.
Minus 1.2.
Around 1.3, right? Let's say 1.2, right? 1.2 to 1.3. Now, due to the imperfections of your setup, right? Real stuff always is imperfect. You'll get slightly less than 1.28. I believe this 1.28, right? You get around 1.2 if you use the very traditional material of zinc and copper. Zinc is available, copper easy to get, and this is one of the first few batteries that they actually make from the, from which works, so to speak. This is where the 1.2 value comes from. Do you understand what I'm saying?
Mm-hmm.
So if you want to replace the copper with the zinc, then you're dealing with a theoretical difference of these two, minus 2.33 with minus 0.76. You understand what I'm saying?
Yeah.
You can predict that to be around 1.57, I think. Is that correct? Around there?
Yeah.
Okay. Which is better than 1.2. So you do what you want. Do you want aluminum zinc? Do you want to have zinc copper? Do you want aluminum copper? That's up to you because you have 3 requirements to deal with, if that makes sense.
Yeah.
You have all other materials in between also, in that sense. Okay. This is the first thing I will show you. Right. Any questions so far?
So because they provide us with zinc, so if we switch out the copper with zinc, it will still work, right?
If you don't use the zinc, it should work better
Oh,
because there are things better than zinc, higher and lower. You should always strive to create the biggest voltage difference.
mm.
If that's what you want, if that's what you want, you don't have to be stuck with zinc. Zinc is just cheap, but aluminum is not difficult to get, neither is copper. That's why I say the material choice is not bad. Sticking to zinc doesn't give you too much benefit, I would say, if that makes some sense. Okay, maybe criteria 2 and criteria 3, maybe you want to consider it, maybe, but I don't see much advantage right now, if that makes some sense. Maybe put it as plan C, if aluminum and copper somehow doesn't work, somehow gives you very weird thing because there are always troubles when you deal with something realistic. But keep it as plan B or plan C, if that makes some sense. So far, so good?
Yeah, so it is doable, right? Like, does it take most, if not all, of the challenges?
Regarding the design, that's what I need to ask you. I need to ask you about design. Stay with me for a while. I'm gonna have to ask Tristan for a while, okay? Okay, I'm gonna ask you the design one very soon. Tristan, you are no longer stuck, isn't it?
Yeah, I'm trying something else.
Okay, good. Good, good. Okay. Now back to you, Ria, the design thingy, right? So there you go. Now, let me tell you something about portable, okay? This comes from the history of the development of battery. If you use any form of liquid, it is almost certainly not going to be very portable. Do you understand what I'm saying?
Wait, could you repeat?
If you're using salt water, the problem is that it is water.
Mhm.
The problem is not the aluminium or the copper. The aluminum copper are, metals, very easy, very compact, very portable. But if you have a liquid will spill, Once your electrolyte, salt, water spills, your battery is gone, right? Battery doesn't work anymore. It's not that it'll explode. Nothing will explode here. Nothing dangerous will happen here, right? But it will not work because it spills. A liquid inside a jar is not portable at all, is what I'm trying to say. You either have to find a way to deal with the liquid because it will work, but you have to make it sealable or you have to make it cannot spill. Because the point is, why would you want to carry a battery which can spill? It doesn't make sense. You either have to make it non-spillable, the liquid somehow, or you replace the liquid somehow, or you make it, I don't know. You get what I mean? That's what challenge 2 means, I believe. It's not the metal.
Yeah.
It's the electrolyte problem. Once you try to overcome challenge 2, challenge 3 comes. So the challenge is really in a difficulty order thing. Challenge 1 is a simple matter of selecting the materials. Challenge 2, you gotta deal with the fact that you don't like the liquid, but you need it. What's the solution here? Challenge 3 will be if you design it very well. Very good, Tristan. Very good. Very good. Do you understand the level of difficulty of the challenge?
Yeah.
Let me put it another way. Your homemade battery will not look nice, original, novel, feature, design, whatever, if you cannot even complete challenge 2,
Mm.
which is most probably the liquid problem. Okay, if your effort is not spent in dealing with the liquid problem or any other problem possible, yeah, the challenge 3 doesn't make sense. It almost doesn't mean anything, challenge 3, if you do not understand challenge 2. That's just the way it naturally proceeds. Okay. Do you still want to talk about it next week? Does it still matter if you talk about it next week?
Yeah.
Well, based on our discussion today, do you have, more things to discuss with your friends lah, so that, next week we can discuss again what you guys decide?
I think we're seeing how to replace that.
Salt water thing, yeah,
Yeah.
somehow lah. Make it portable. Make the battery carryable somewhere, something like that, somehow lah. That's definitely a good way to solve challenge 2. Something like that.
Okay.
Okay, so challenge 1, the material, I told you already. Challenge 2, like that, maybe we'll talk about it again.
Okay.
Hopefully that's enough for today. I will see you not on next week, but on Thursday, right? Correct.
Yeah.
All right. See you then. Bye.
Thank you. Bye.
Okay, Tristan, you're doing the harder and harder one. Good. I like.
Yeah.
Oh, this is hard. This is hard. Why? Because you haven't even learned the surface area of a cylinder. Have you learned that already?
I don't think so. Maybe I did it like once. I forgot. Pretty sure no.
Let me see. Let me see. If you could do it, I'm very impressed. I'm very impressed. Okay. Needless to say, this won't happen in exam lah, because they haven't reached here. But if you want to try, I'm totally up to it.
Okay.
Check your Canadian for today you're going to because it's come from 2 a.m. So it's Spain, then I have to give inflection. Because next Canada, because I want to scan and scan, then I check they given my clip given around 2 a.m. the Canada. And then morning 8 o'clock I give. And then after lunch also I give. So consider it's 3 times per day. So now if you want, then we need to take the injection. Or if you okay, then you delay with the injection. Depends on you. You delay. But the Canadian they can give you around 2 o'clock again. Yes, because if you take the oral medication in the morning, at least you can take longer. I mean, 3 times.
Maybe I can see you, yeah?
So that is the suggestion.
Hi.
If you go to bed,
Hi.
then you take the injection. I will pass over. I stay until 9.
Okay, Tristan, tell me, this area that you're talking about. Oh,
Mhm.
they are given. I'm sorry. They're given. Never mind. Sorry. Never mind.
Yeah,
You
once
just
it's
do.
given, it's a lot easier. That's correct.
Yeah. Cool. So cool. Although time is up, if you want to continue because it's exam,
Oh.
it's up to you. Yeah. Up to you.
Yeah. Okay then. I'll just leave the meeting.
Okay. When I see you next week, confirm don't have exam yet, right? There's still one more time.
23 is on what day? Let me see.
23 is 8. No. 23 is
23
next
on
Tuesday.
Tuesday. Yeah. So won't have any more time.
So are you okay? Because if you're not
I should be
okay, maybe
okay.
you can move it to Monday or Sunday if you want to lah. Depends what.
Oh yeah, I'll see.
Yeah, you'll just see first, okay? If you want,
Okay
just
then.
move lah. All right then. Okay,
Okay.
Tristan. See you then.
Bye-bye.
Bye.
My colleagues will come and remove.
Okay, Kirby, tell me when you're ready. Yeah, I can see. Yes.
Sure.
Okay. Yes, Kirby.
We're
Yes.
doing chemistry today, right?
That is up to you. What do you want?
I'm fine for anything.
Let me see. POA, some math, some. Before we talk about chemistry today, I want to know what you think about the math questions, in the last 2 times. What do you think about that topic?
It's super long,
Yeah, it is.
super
It is.
annoying to read. Yeah.
Which is quite
I
proud,
made
quite
so
proud
many
of you.
so many mistakes yesterday. Like,
Of
yeah.
course, of course. Yep, yep, yep. As in, do you think the topic is worth doing lah?
Yeah.
Okay. Not
Worth
every topic
practicing.
will be that long, right? Not every topic will be that long in terms of
Yeah.
reading lah. Let me put it this way lah. Do you think if you do those topics, regularly, not everything, not everything. Math is not just about that topic. But if you do it regularly, do you think your reading skill will improve?
Yeah.
Okay.
Probably.
Then, for the purpose of improving your reading skill, we should do that from time to time, just like POA. POA, I focus on, the longest question because that's the most reading, so to speak, the most reading.
Yeah.
It'll make you feel better when you look at the other questions. And frankly speaking, after a while, you seem to be able to read. You seem to be able to understand the question quite fast, right? Even though it seems slow, but you're improving. To gain B, let me put it this way. To gain B, B3 or B4, reading skill has to improve. If your goal is C, your reading skill currently is fine. Something like that. I hope that makes some sense.
Yeah.
If you want to gain A, A2 or A1, then of course your reading skill must be better. Right? Having said all that, I can see it improve slowly. So if you don't give up, you'll get it. You'll get there. Okay.
Yeah.
Now, so today, still chemistry?
Yeah.
All right. Then would you please open the table of content for me? Chemistry is supposed to be your best topic. Yet there is something that bothers me, and it's not QA, it's not your memorization. It's just that that's not what bothers me. What bothers me is definitely acid and base. No, yeah, that's it, acid and base. That bothers me a lot. I did put that as big, topic 6. Should we do this today? Let's just face it, let's just deal with it. Okay. You have a Jamboard which contains the summary of acid and base. I want you to go to that Jamboard and just look at it for a while. Meaning, I'm testing your organization. Do you even know that you have a summary of acid and base in your Jamboard? Okay, give you 2 or 3 minutes to go and find.
Okay. 我要 try from the sure. So
Sorry, Kirby, I heard you. I heard you. I was helping my wife just now. Sorry about that. Yeah. You found it. It has a list of acid and base and whatever, correct?
yeah.
Remember how I teach you to memorize. You read for 1 minute. You don't remember anything, but just read for 1 minute and then immediately close it and rewrite it. This is a warm-up, okay? I'll give you 1 minute. If you want to clarify something, also clarify. What is this? What is that? After 1 minute, just close it, rewrite. Okay.
Okay.
Okay. Almost 1 minute. Are you ready to close your Jamboard? Kirby?
Yeah.
Close. Are you ready to close your Jamboard?
Yeah.
Okay. Just close your Jamboard, take a paper, rewrite everything first. Let's see what happened. Right?
Okay.
Use the chemistry. Yeah, good. Use that. Yeah, use this. I like it. Do you feel more organized these days?
Yeah. Because I have a book for my physics and chem and
Looks
book
good.
for my
Looks good. Looks
yeah.
good. Looks good. Organization need not be hard, right? You know. How do you find your study table? Do you hate it?
Uh it's okay.
Okay.
I used to use this for gaming, but I got a new table, so
Yeah. The going up and down one, right?
yeah.
Yeah.
Wait, Trevor, before I close the Jamboard,
Yes.
what's
Yes.
MOFF?
MOFF.
Is
I'm
that
sorry.
metal oxide?
I'm very confused. I don't think it's MOFF. I think it's
Yeah.
MOX. You share your screen. Share your screen and just show me. Easier that way. Okay. Which one are you talking about?
Uh, next to MO and metal.
Oh yeah. Okay. It's not MOFF. Sorry, my writing very bad. It's MOH, metal hydroxide.
Oh, the MO
Okay.
is metal oxide.
Metal oxide. Yes. Metal
Okay.
oxide. When you're ready, don't look at it, and just
Yeah.
do it lah. Just do it.
Okay.
Yeah, I want you to switch. Yeah. Okay. Switch the gem. Yeah.
Acid and base. Right. Rachel, can I go wash my hands first? It feels a bit sticky.
Quickly, though. Kirby, are you okay, Kirby?
Yeah, I'm putting the ear thing into my ear.
Okay. Okay, so far so good, Kirby. It's not supposed to be a very long list, right? So maybe I'll give you 1 or 2 more minutes, and then after that, we'll, change color and correct, right? We should not get used to spending a lot of time remembering things. Should get used to a shorter time.
I give. I
Yes,
don't know.
Kirby. Yes, Kirby. I cannot hear you. Kirby, you're saying?
Hello.
Yeah.
Hello.
Yeah. Slightly clearer. Yes.
But it's like right next to my ear. How come you can't hear? Hello.
Yeah. Yeah. So just now it wasn't very clear. Now it's better. Yeah. Can you hear me now?
Yeah.
Okay. Good. Good. You're saying. You're saying.
I gave up. I don't
No
know.
problem. No problem. Remember, when you memorize, especially when you're rusty, you're not supposed to get it right the first time, right? Instead, you
Yes.
should do this and then change color and then check your Jamboard, lah. Check your Jamboard and then just correct your mistakes, lah. That's how you memorize.
Yeah. So I checked the answers now, right?
Yeah. Check the Jamboard, lah, yeah. But remember, change color, yeah. Then
Okay.
Kirby, why are you not correcting, Kirby?
Opening up the Jamboard.
Oh.
I think I'm done. Done with the correction.
Yes, Kirby. Now let me check. Yeah. The cowards you have to know. Cowards.
Yeah.
Yeah, good. Yeah, good. The H2SO4. You didn't correct your H2SO4. Come on. H2SO4.
It's true.
Yeah, H2SO4. The formula is wrong. Okay, understand? There's a 2 there. Okay. Don't close the Jamboard, just shift to a different page so that you don't have to open again. Close this, rewrite it one more time. It's a short list. Okay. Like
Okay.
right now, don't bother to rememorize. Just do it one more time and then we're done. Right?
Yeah.
Okay. Please do so.
Try to the next page. Go on to the next page.
Can also, as long as you just don't see it out of your memory. Okay. Show yourself that you can memorize, rather easily. Okay. All right. Definitely some improvements, I guess. Some. Yep. Looking good so far. Looking good. Are you ready?
Yeah.
Okay. Go ahead and check
Okay.
with a different card. Good, good. Good. Very good. Now, hopefully, Kirby, this is an example of how well you can memorize before exam. If tomorrow's exam, you done this part already, no? Okay. This is how you should memorize. It seems to work with any sort of memorization that you need, right? Except for history, I think history is just treated differently. Then again, you don't have trouble with history. You only have trouble with this kind of thing. Seems to work. Good news, right? If this is before exam, by right, you should be doing it faster simply because you don't have, the whole day to memorize. But for today, it is as simple as that. It is really as simple as this. All right? Okay. Good job. Any questions?
No.
Then I have a question for you. The exception. Metal oxide, except, right? Non-metal oxide, except. So for the metal oxide, except three things. What does those three things mean?
Zinc. What do you mean? Like what they are?
Yeah. So because it's an exception, so what does that mean?
Oxide. Huh? What do you?
Yeah.
Give
Why
me
is zinc oxide, aluminum oxide, and lead oxide an exception? An exception to what?
an exception of being a base.
All right. So let me remind you again. The exception is that they are called amphoteric, meaning to say they are base. They can also be acidic oxide. What does that mean? So if they are in a same place together with another acid, they behave like a base. So normal metal oxide, no? If they are in the same place as another base or another alkali, they can actually behave like an acid. In that way, they are amphoteric. They behave depending on the situation. That's the exception or what it means. So far, so good?
Yeah.
The acid exception, non-metal oxides are acidic except, CO, NO, and H2O. So what does those exception mean?
Means as amphoteric.
No, means they're neutral. They are neither acidic nor basic.
Oh yeah. The notes say that.
Yeah, so they're called neutral. So the exception in non-metal, they are neutral, non-acidic, non-basic in whatever situation. The basic exception are they can be both. Please write it down and then let's move on to your TYS.
Like, how do you spell amphoteric?
AMPHO.
AMPHO.
TER, amphoteric. TERIC.
T
Now,
T or A
RIC. TERIC.
TERIC.
Now
Okay.
explain that to yourself what that means, okay?
Can be alkali, right? Right? Sure.
I mean, it's already basic, so it can be acidic or alkali depending, lah, right?
Be anything. Trans.
Depending, yeah, depending.
Yeah.
Okay, the other one is neutral. All right, so good job, right? That's the thing that we need to start with, lah. So let's go to TYS, lah. Right?
Okay. What subject? Are we doing SMB topic?
Yeah lah. You know, that's the last big thing that you need to
Which one's
confront.
SMB? Oh, yeah. Big
There you go.
things.
Yep. Let's try.
I read the song.
Some, okay. I mean, we can move on for now, lah. Just do what you haven't done.
Yeah. Yeah.
Okay, there's something there. Right. Could you zoom in a little bit, please?
Okay.
Just a little bit.
But are you still in the hospital?
Yes, I am. For this
Oh.
week, I will be lah. I will.
The entire week? So long.
Until Wednesday night, which is tomorrow night, lah.
Oh. Okay. Potassium's a non-metal, right?
Potassiums are metal.
Oh.
Potassiums are metal. And it is good for you to ask because you do need to know. Could you kindly shift your camera, please? I cannot follow.
What's potassium? It's K, right? K.
It is K, yes, in group 1, so it is metal.
And the aluminium is Al2O3.
Your potassium oxide formula is wrong,
KO2.
and it's even worse now.
K 2KO.
Yeah, K2O, yes, K2.
Oops. Oh,
Well, there you go. There you go.
that's it. And what's a base? Base.
Okay, it's basic. Yeah. So far, so good, right? So far, so oh, for 6 marks. Well, that's.
6 marks? Oh.
There you go. That's quite okay, right? Quite okay. Okay. I still have to correct you, lah, yeah. Okay, but this shows that what you just memorized is helping you right now, right?
Yeah. Substance that is used to raise the pH. Which I use potassium, right? Base.
Raising the pH does mean you make it more alkaline, true, but using potassium will be very dangerous because simply potassium is dangerous lah. Potassium explodes lah in contact with water. So I don't think you can just say that. Now put it another way. Let me put it another way. You should think about for farming purposes, you should always think about either weak acids or weak base, weak alkali. So not the strong ones lah, not the strong ones. So in this case, you want to talk about an alkali which is weak, not strong. Potassium metal is very, 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 very strong. Not recommended at all. Dangerous lah. Okay, what? You know what? For this thing, it's just a memorization. Never mind. Certain things in SNMPs are memorization. So you just look at the answer key and you tell me whether it makes sense or not. Would that be okay?
Yeah. Oh,
Now, what is that?
your question is question 5.
Mhm.
It's not the answer key.
I'm sorry, I cannot even see the answer key. Sorry, can you show me question 5?
It's
Sorry.
not 7.
Uh,
It's not question 5. But is this
uh,
question 8? Oh no, that is
yes, there is. It should be like it's not a very difficult thing
slaked
to.
lime calcium hydroxide.
Yeah, the metal hydroxide lah. The metal hydroxide, calcium group 2 lah. Group 2 is weaker than group 1 generally. So you don't
Yeah.
choose the group 1 stuff, you choose the group 2 stuff, and hydroxide are generally weaker than the metal itself. Generally lah. Okay,
Yeah. Yeah.
so memorize it if you will. Slake lime is. But the most important feature of calcium hydroxide is that it's cheap lah. That's the most important thing. It's cheap and it's not dangerous. So that works. Okay, let's go back to question 7.
Mixing equal amounts of strong acid and strong
Could you show me
calcium.
the question? Okay, could you show me quickly? So this is already something. Oh yeah, okay. This is already not
What's
what we
it?
talk about.
I don't know. What's it?
This is neutralization or titration, either titration or neutralization.
Titration.
Yeah.
Titration.
Or neutralization.
Okay.
Okay, I've never asked about your practicals, Kirby. Now,
Yeah.
how many practicals did you do for chemistry?
A couple. I don't know. Practicals are confusing. Normally.
I'm sorry, you're saying?
I don't know a few, but it's confusing. So I normally struggle
Mhm.
for chemistry practicals.
You mean physics practicals are better?
Yeah, it's easier.
I mean, I won't blame you lah. Chemistry practicals will feel weirder or less natural lah, right?
Yeah.
So when I mention the word titration, you might not even understand that, from the practicals.
Yeah.
Oh, I see. Okay, let's move on for now. Now, the next question is clearly practical, but it is a practical that is standard. It will appear in exam, and it is not difficult to understand, even if you have known previous knowledge. Let's talk about the next question. As you can tell, there's also quite a lot of marks lah. Okay, let's look at it together, but you're going to read them first lah.
Okay. Oh, 6 months. Oh. Wait, can I go get my headphones? My ears starting to hurt.
Please do. Please do.
Okay. Hello, Che.
Yes, Freddy, I can see
Oh,
you.
you're
I
back.
can hear you. Okay. Yep.
Oh, I went to use the toilet.
Okay.
I
All right.
got the thing.
All right. Right. Regarding the headset, right?
Yeah.
You know that using headset is, feels better lah. So is this the old headset that is a bit run down?
Uh, yeah. It's about to fall apart.
Are you using it for gaming?
I don't normally use it. Cause I normally use my AirPods, but my AirPods can't connect to my computer. So when I use my computer's audio, I have to use my headset. Yeah.
You mean your laptop, is it? When you use
No,
your laptop,
my computer, my PC, you know.
your computer, your PC does not have a Bluetooth connector. That's
No, it just I don't know, it just doesn't work when I try and use my AirPods with it.
you're saying that you have a normal speaker, lah, right? That's what you're saying, right? For gaming, that's what you usually
On
do.
my PC.
Yeah.
No, I don't have a speaker.
So every time you game, you do use this almost falling apart headset, lah, correct?
Uh, Not really. Normally I just play without sound. Then I use my AirPods to play music or something.
You play without sound, really?
Yeah.
Uh,
But
I'm very
I don't need sound.
Okay, all right. Okay, look, I want you to have a, I want you to have a tuition only headset. It doesn't have to be
Tuition.
expensive. It just has to be good enough, lah, right? With the mic,
Yeah.
because mine is not the best thing also, right? Mine is not the best thing, right? Correct.
Yeah.
Either you buy by the end of this week, or I will send you either one. Now, which one?
I think
Okay.
I'll buy one because I just asked my mom before I came down
Hmm.
if she could
But
get me a headset. She said sure. So
but I do not want you to run up every time because you're using it for gaming also.
yeah.
So
Yeah.
it will be exclusively for your tuition. So it doesn't have to be nice, lah. It just have to be usable. All right.
Okay.
Now, if there is no progress by the end of this week, I will buy and send to you. Okay? Would that be
Oh,
okay? Okay. We've been
okay.
waiting for too long already. Later you buy 3 months from now, then you get what I mean.
Yeah.
I don't want this problem to make our tuition bad. Would that be okay?
Yeah.
Right. So at
Mm,
the end of this week, I will ask. If not, then I will send you. Can yeah? Agree, yeah?
yeah.
All right. All right. Please continue reading again. For some strange reason, there is a
Okay.
very long question here right now. Okay, Kirby, how about the reading so far? Please ask me what you don't understand.
Uh, wait, H2 is a gas, right?
H2 hydrogen is a gas, but how come you're
Yeah.
asking me about hydrogen?
Because I was thinking about how like, or where the H2 goes. 'Cause if it's a
Okay,
gas,
okay.
it can just like it just go into the air, right?
Correct, correct. So you don't have to worry about it, and
Yeah.
you are not wrong. You are not wrong.
Uh, I don't. What mistakes are there? How am I supposed to know what
Okay.
is a mistake?
First thing, sorry, sorry. Can you hear me?
Yeah.
Now, do you understand the procedure first? Because the procedure is kind of standard and it is good to understand it anyway. If you understand the procedure, it's easier to figure out the mistakes.
I don't understand the procedure. You explain.
Okay. Okay. So now, in the Jamboard, please. Yeah.
Which Jamboard? Is it Jamboard 6?
I believe so. Yeah, I believe so.
Okay.
Okay, please go in the last page, I believe.
Okay.
Just a minute, I lost my pen. Yeah, I did found it. Okay.
Yeah, I'm there.
Okay. Uh, let's just say that number one is correct. Yeah. Okay.
Yeah.
So iron fillings. Tell me what this is. I cannot read
Iron. What do you mean?
this thing.
Uh,
I cannot see it.
important to recycle metals
Important,
such
important.
as
Okay.
iron.
Okay. Yeah. Yeah. I'm big. Okay. Never mind. Sorry. Important. Thank you. Then iron filling. So iron filling. Thank you very much. Iron filling. What is iron filling in terms of chemical formula?
Uh, Fe.
I
Fe.
agree with you. So that should be
Fe
Fe.
something.
Okay,
Fe2.
Fe and then solid. No, no, it is Fe.
Oh
Metals
yeah,
are
yeah.
only Fe, right? And then
Fe.
warm excess filling with concentrated solid. Okay, yes, correct. So and then he tells us that it will become like this, something like that. And then you're saying that this is plus H2, at least according to you. Am I correct?
Yeah.
Okay, now try to balance this first. It's a good exercise anyway.
Uh, okay. I think I did it. Right?
No, still not balanced. It's a good start.
Huh? Oh, is that it? Did I do it?
Uh, how many SO4 on the right hand side?
Uh, 2?
Hey,
Was it 3? Should I do it? That's
It's
3.
3, right? It's 3,
The 3, then
right?
the FE is 2, right?
I think so, yeah.
And then
Yeah.
the H2 is also 3.
Okay, so that's okay. And the F is only 2. Okay, good. So far that is balanced now, yeah. Now, equals, yeah, okay, yes, okay, good. Now, this is excess. We never talk about excess properly lah. Do you know what excess means?
Extra.
Correct. So when the Fe is extra, it will be left over. If that makes sense. After the reaction, it will be left over
Yeah.
lah. So this is limiting law. That's the fancy word lah. So if one guy is excess, the other guy is limiting. That means it will finish first. Limiting means you will finish first, not extra lah. Right?
Yeah.
Extra, non-extra. Right? So that makes some sense. And then is it possible for both to be in excess?
No.
Because one will run out first, if that makes sense, right? How can both be
Yeah.
extra lah? If both is extra, then both continue to react, no? Right? Hope that makes some sense.
Yeah.
Now here's the thing, I guess. So when you're trying to make H2SO4, there you go. When you're trying to make Fe2SO43, sorry, Fe2SO43, you notice that this is an aqueous thing, correct? You notice.
Yeah.
This is something very important for practicals. So this is a knowledge that you should have anyway, right? So I just say it to you. If I'm making something aqueous, should the extra, the leftover, be solid, or the leftover be the aqueous? Remember, this is solid plus aqueous, right? So who should
It
be
should be
left?
the solid.
Okay, if this is a leftover, then automatically the other one is not a leftover, right? Automatically,
Yeah.
leftover, not leftover. Now, you are correct. Why so? Why?
Because the liquid will evaporate. Yeah.
No, because this will contaminate if it is leftover.
Oh.
And this
Yeah.
actually easy to separate. That's the clue. So if it is easy to separate, it does not contaminate. That is the meaning of contaminate. If you contaminate, it's very difficult to uncontaminate. Something aqueous, mixed with something aqueous, is almost impossible to separate most of the time. Most of the time, you just don't want that at all. So from the raw material, I notice one is solid, one is aqueous. My goal is aqueous. I want to make sure that the aqueous is not leftover. The leftover solid is totally fine, easy to separate. Does this make any sense right now?
Yeah.
Now, knowing this simple practical logic, this is a practical logic. This is not too much of a theory, but they expect you to know. Knowing all this, did the student make any mistake regarding this? What do you think?
Yeah. Wait. How come he start with iron fillings? Why does he?
Okay.
Why
What
does
do
he
you think?
say that? Can he just remove that line? It's like
Sorry,
not needed, right? Why
I'm
does
sorry, you're
he
saying?
need to? Why does he say start with iron filling?
Maybe
Can
the
he just
question is
say
more like,
warm excess? Oh wait. Oh. Yeah. Oh yeah. Then
maybe,
that's wrong, right? That's wrong because he says it's
why is it
excess,
wrong?
right? He says iron fillings is excess
Excess. Okay. Tell me again, why is iron filling excess wrong?
because it's leftover and wait no
Uh,
wait.
but
Oh wait, that's
we talk
correct,
about
right?
that's
Oh
correct.
yeah,
Yeah, it's
wait.
correct
Never mind.
because
Never mind.
If that is left over, the other guy will not be left over, and so the other guy will not contaminate, which is a good thing, right? So he
yeah.
started well actually. Regarding why do you write start,
Yeah, that he's
I
correct,
don't know. Then
right?
okay, in that respect, he's correct, no? Right?
Yeah.
And you realize that he's correct. Is what is my point. You realize that at
Yes,
least he's not
I
wrong
agree.
there, and this is important because in another question they will test you one, right? Oh, they will test you the fact that it's wrong, like something like that. Okay, makes sense, huh? So okay, this one is what is the first thing that you should look for, and at this point, okay lah, I agree with the student. Okay, so far so good. Okay, let's move on for now. Let's move on. Now, I want to revise your redox number. So back then, actually, I don't think you have learned redox in acid and
Oh
base.
yeah, I'm
But
not
this is a
completely sure.
TYS. But this is TYS, so they don't care already lah. They can and they should test your redox in acid and base because everything is now allowed. So tell me, what is the redox number of Fe?
Uh, uh,
Look at the
oh,
reaction. I don't want you to look
um,
at the question. I want you to look at the reaction.
2.
The reaction is there because, okay,
Is it?
right?
It's
So
2.
now, first of all, I wasn't asking Fe2SO43. I was asking Fe.
Oh, then 1.
No, it's 0.
Oh, it's in 2. Huh?
No, it's
0.
0. 0. In the same reason why H2 is 0. Okay? This is covalent bond, right? It's covalently bonded. This is metallic bond. Am I
Yeah.
making any sense? Tell me.
What's a metallic bond? I only know the
Ah,
ionic and covalent.
Covalent, correct. For some reason they don't teach you metallic bond. It's so annoying because it's so easy. Metallic bond are just metals, lo. That's it, lo.
Oh,
Right. I mean, you don't know
so
exactly what metallic
it's
bond
0 if it's a
is
metal, if
because,
it's
yeah,
a
correct.
metallic
Because
bond.
it is just bonding with himself. This
Oh,
H2
yeah.
is just H bonding with himself. There won't be any competition or unfairness between them, lah. In the electron sense, they won't be. So it's always 0. So metals are usually always 0, and H2 are usually always 0 because there is no competition or are you winning, losing between them. So far, so good. Done.
Yeah.
Okay, now this Fe will be different because this Fe no longer exists as a metal, but it exists in an ionic bond, right? And so
Yes.
this Fe will be something else other than 0. Now, tell me, the SO4, do you know the SO4 is how many plus or how many minus?
Uh, SO4
Mhm.
is
Now you have a problem because you should have seen it very quickly. Don't look at it. I'm going to teach you. I'm going to teach you. I'm going to teach you. Come, look at the Jamboard again.
yeah,
The
yeah,
H here is +1 because that's how you start redox.
+1.
H in another setting other than H2 is always +1. Okay, I give
Oh,
I give my electron to you. That's what H is saying. H is very, very kind, very donating, +1. Because H is +1 times 2, right? Times 2,
yeah.
SO4 will definitely be 2 minus as a whole. Do you understand?
Yeah,
Okay, this is +1 times 2, so 2 minus. Now, the SO4 here still remains 2 minus. Okay, it still remains 2 minus. You can say this is 2 minus times 3 lah. You can say that. Would that be okay? So a total of
yeah,
6 minus lah. In a total of 6 minus. Now, this Fe will also be in a total of 6 minus, 6 plus, I'm sorry. It will be in total of 6 plus, correct? 6
yeah,
minus 6 plus, which means this is 3 plus times 2, which means it is 3 plus times 2. Am I making any sense right now?
yes.
So, if it doesn't make sense, please tell me immediately. Make sense or not, Kirby?
Wait, how come I don't understand the
Okay.
FE part.
Okay, one more time. The SO4 remains 2 minus. The one you can accept. Okay? As the
Yes,
whole
2
SO4 2
minus.
minus. There's 3 of them. He say one or not I say. He say. So in total, you have to contend with 6 minus. Lah.
Yeah.
Put it another way, SO4, each SO4 demands 2 electrons. So 3 SO4 demands 6 electrons, correct? From somebody
Yeah.
else. So who will be donating to them? Well, it'll fall to the hands of the FE. The FE will be
Oh yeah.
donating 6 plus in total. However, there are 2 FE, right? FE2, there are 2 FE, so they share their burden. Each will donate 3 instead, each. And that's what we're looking for. Each will be
Yeah.
3 plus. So in total, they donate 6 plus. Would that be okay?
Yeah.
Would that be okay? So this is
Yeah.
the first mistake that the student do. First mistake. Do you realize that? This is the first mistake.
Oh,
Why is it the first mistake?
first the redox thing, right?
I'm sorry, what?
The number thing.
The number thingy? Right, okay, tell me again. Why is it wrong? Sorry, tell me again.
Rachel, why is it wrong?
Because
I
he won
zoned out.
FE2, not FE3.
Oh yeah. Oh.
Hello. Yeah, hold. Okay,
FE2.
so he's doing it wrong lah, so to speak, like he's doing it wrong. Okay,
Huh?
he's doing it wrong, look. Like he's asked to do Fe2 sulfate. He makes Fe3 sulfate or whatever. Like his end result is not Fe2 sulfate. Do you understand what I'm saying?
Huh? I'm
Okay,
still
one
I'm
more
a
time.
bit confused. Oh,
Okay, one more time. One more time. Okay, one
yeah.
more time. This is what they are asked to. This is the goal, right? Now, let me ask you: Is this Fe2 SO4 3? Yes or no? Yes or no?
No.
You are correct. This is not.
Yeah. It's just
Let me
FeSO4, right?
absolutely FeSO4 is Fe2. Fe2SO4 3 is called iron 3 sulfate.
Yeah.
I hope that makes some sense.
Yeah.
So that was the mistake lah. That was the mistake. Okay.
Yeah.
Okay. So first thing first, you can write it down.
Uh, Wait, so I read down he wrote Fe2SO4
Yeah.
3
Just write
minus
down
instead of
Fe2SO4 is fine. Yeah. Just write down Fe2SO4 3 is fine, and then just give the correct alternative.
done.
Okay, yeah. Now, so far so good. Right now, the second mistake is easy to spot, hard to correct. Let me explain. Is the color of the crystal. Okay, the color of crystal is very difficult to memorize. Colors are not logical. It's just not logical at all. Yeah? You cannot really predict it too much. Now, the brown, however, is still easy to suspect to be wrong because Fe3 plus, you know it's reddish brown. Fe2 plus, you know it's like dirty green. Making any sense right now?
Kind of.
If
So
you do not
it's
know,
not supposed to be brown.
Yeah, because brown is like close to reddish brown. So even though
Isn't
Fe,
brown bromine?
I know, but bromine is not the only brown. Bromine is not the only brown. There can be other
Oh,
brown tones. If that makes sense?
yeah.
It makes sense, huh? But the point is this: hey, you're aiming for Fe2, not Fe3, huh? Fe3 tends to be reddish brown, so Fe2SO43 might be brownish. You wouldn't know. The SO4 might have an effect that you don't understand, but it should be rather brownish. Your aim is FeSO4, which is Fe2, so it should be rather green instead of rather brown. That's the guess
Yeah.
that you can do. Make sense? So this is a guess mistake. You're guessing because you don't know, but it's a very good guess. Okay, the crystal color, right?
Crystals were gonna be brown.
Your guessing is more like a greenish color. So again, you do not know the
But
color,
it
okay? But
should
you're
be
guessing green,
more
I
green.
guess.
Should
Yeah,
be green.
yeah.
Okay.
So that's the second mistake. Now,
Yeah.
the third one I'm nitpicking, I'm not really sure, but something like this. The part which is leaf to stem, the leaf
Huh?
to
Which
stem
one?
question part, sentence
Oh
5.
yeah.
Okay, so what they mean is that
What? Hello? Uh,
again, I'm not sure because I'm nitpicking. So,
oh.
hmm, okay, I don't. Okay, I'll try not to nitpick. So, what is supposed to happen is something like this, huh? In the solution,
Huh?
there is
Yeah.
Fe 2 plus and SO4 2 minus flying around. Remember, it equals one, right?
Yeah.
Now you heat it gently so that the water evaporates. Why would you want the water to evaporate? Do you know that?
Uh, to to get the crystals.
Correct. And the reason why that happens is because the Fe2SO4 2 minus gets very compressed or very concentrated if you reduce the water. Think about this
Yeah.
for a while. The Fe2 plus doesn't evaporate, the SO4 2 minus doesn't evaporate, the water evaporates. So you're left
Yeah.
with very little water, but a lot of Fe2 plus SO4 is cramped. You're cramping them. Once you cramp them, after a while, crystal will form because you're forcing them to cramp itself. You're forcing them. Okay, understand?
Yeah.
So what is the mistake in question 5, sentence 5 is because I don't know what I'm thinking about. You're supposed to heat it until almost no solution, almost no liquid is left. Almost no
Heat
liquid is
until
left.
no liquid is left.
Almost no liquid is left because that's where you get the maximum amount of crystal. If the crystal starts to form, you may still have a lot of liquid. You shouldn't stop. You should continue heating it until the liquid is almost gone. If that
Gently.
makes some sense.
Yeah. Heat until brown crystals begin to form. Heat until almost no liquid is left. Okay. Do I check the answer key now?
Not yet, not yet. There's one more thing. Wait, let me check
There's one
here.
more?
Let me check.
Wait,
Let me check.
tick
Let me
off
check one more thing. Because I think I'm nitpicking here, but I just want to consider. It is possible to have more than what do you call it? It is possible to have more than three mistakes, you see. me check here. Okay, I don't think so. So drying using filter paper is in general a good idea, I guess.
Oh,
Yeah, let me check one more. I think it's fine. So go ahead. Okay, go ahead, check the.
uh, it says that the first one is that instead of using concentrated sulfuric acid, you should use dilute sulfuric acid.
You are correct because using the dilute one will produce the FeSO4. If you use the concentrated one, it will be too strong. It will produce the other guy, something like that.
Yeah.
Okay, all right. Next,
Then the thing that we wrote was correct.
the brown crystal, is it? Sorry, what?
Yeah.
Oh, the brown. Okay.
The brown crystal and the Fe one.
Oh, that's number 2 and 3 to them. To them, that's number 2 and 3.
Yeah. They have
Oh.
4 things in there.
So number 4 is?
Number 4 is washing with large quantities of distilled water, and instead of that, it should be
It shouldn't be
wash by
large, isn't it?
squirting a small quantity of distilled water.
Yeah. No, no, that is correct.
Wash water.
I thought that is you're correct, because if you wash it with too large, it will dissolve. Then you have, you're washing too much of the crystals away. Something
Yeah.
like that. That's fair. So I think the leaving to stand might be nitpicking. I mean, I would have phrased it differently. I would definitely phrase it differently. Okay.
Yeah.
The concentrate and dilute one, I guess that's valid because again, you're supposed to use dilute to get FeSO4. Concentrated will give you Fe2SO4. Right?
Yeah.
Remember all this? This is a very big question, so it's difficult to forget. Next time you see a similar one, I guarantee one thing, they look similar. They sound similar, they feel similar. So referring back to this question should help a lot. You don't need a special note, so to speak, if that makes some sense.
Yeah.
Okay. Now, please complete your answer by by using the answer keys answer. You understand? Just put it here. Then you don't have to refer to the answer key anymore.
Okay.
We will call it a day for now. No, I'm sorry. I should give you one more question to do because you're a bit late. A little bit only, still quite.
Yeah, I'm done.
Okay. Okay. Remember this page, it will be, it's already QA. Okay, one.
Oh.
Okay, wait. Okay. Your last question, I will log off now, right? But you have to do your last question. I prefer that you don't do the QA. I prefer that you do the next page one. I prefer lah.
Okay.
Okay, which is that one.
This.
Okay, this one. You will notice that it is a little bit similar to what happened. A little bit similar, right? Please do this one. Show it to me tomorrow. I noticed that you are improving in your on time. Okay, you are better than yesterday. Yesterday was 2 days ago. I appreciate that. I want you to be even better, and tomorrow on time. Okay. Really, I appreciate the effort. Please do this one, and I'll see you tomorrow.
Okay.
Bye.